topic is called substitution, where you substitute a letter for a number. Okay, so in the past you may have known some of this as algebra. Okay, and all algebra is, I know it freaks us out a bit, all algebra is we've got an unknown, value. Okay, and what this is telling us is that if we start to know what those unknowns are, then we can actually solve that problem. Okay, so in this one, we're saying A plus B. This one, what is this saying? What's AB? What's missing in there that you know in terms of a plus, minus, divide or multiply?
Times.
Yeah, there's a times, and where's that showing?
A times B.
Yeah, this actually reads A times B, but now you're in Year 9 maths, we sort of drop that away and it just comes as AB when they're just as letters, okay, or unknowns, which is what we're saying here. And this is A plus B divided by 2, okay. So if the question was to ask you to maybe calculate or even simplify the following, A plus B, where you know that A is equal to 3 and B is equal to 7. Okay? So that's how a question would be worded. Simplify or calculate given that A equals 3 and B equals 7. So all that's saying therefore is you now know what this is and you now know what this is. Okay? Now A is 3 and B is 7, and so we can simplify that to 10. Yeah? That's alright. This one here we know is A times B, so how would this read back?
3 times 7.
3 times 7, and that is?
21.
21. Good. And Chris, this one? 10 divided by 2. 3 plus 7 divided by 2. 3 plus 7 is 10 divided by 2. 10 divided by 2 is 5. Okay? Now, they don't get much more difficult than that, but the issue that I want you to understand is when we start to get A take B. Okay? So the thing that I want you to understand with the substitution or with any of this is that this sign here belongs to the letter or the number which comes after it. Okay, this belongs to this. Alright, so where we've got A equaling 3 and B equaling 7, the negative sign belongs to the 7. Okay, so one thing I want you to always remember is the number or the letter which follows a sign, they belong together. Can you always remember that? You need to always remember that. Alright? Which is not too difficult in this circumstance. What's 3 take 7? So we're talking about that number line now, aren't we? So there's going to be negative numbers in your test. So 3 take 7. Chris?
-4.
It's at -4. Remember our number line looks like this. Alright, and if we're saying what's 3 take 1, alright, for 3 take 1 we'd go, I'm taking 1 so I'm ending up there. So every time I take, remember we go that way. This one we're starting at 3 and we're taking 7. We're starting at 3 and we're taking 7. 1, 2, 3, 4, 5, 6, 7. We end at -4. Okay. Another example that we might do is A plus B. What's that saying there? A plus B. Where A equals 3, B equals 7. How would you go about this? What's your first step you'd do, Beck?
3 bracket 3 plus B.
Good. 3 bracket 3 plus 7. Excellent. What does BEDMAS say? We must do what first? Brackets. Okay. So that's 3 just as Cheyenne said before, Beck, there's a multiplication sign in here. Okay? So 3 times 10 becomes 30. Alright? So this is the, I guess, toughest part of what your test will be. There'll be this stuff in it, okay? And there'll be negative numbers. If you don't know how to use this, alright? If you don't know how to use that, I suggest you start learning this week. And as soon as you get your test paper, draw a number line on it, remember how to use it and that sort of thing, okay? Or have your ruler available to you, alright? So you need to understand that stuff, which I think you're probably working through at the moment. In the past, what we've had is a sum similar to this, and what's the process that we've used? I've given it a name, it starts with F. Jess, Manners? No. What's the process we go through? It starts with F. Dougs? Foil. Foil. Remember the foil process that I spoke about? First outers, inners, last. You were here for that, Jess. First outers, inners, last. You weren't, Jess? Last Thursday. Okay, so first outers, inners, last. So first outers, inners, last. Okay, so there was one or two ways of doing this. Okay, we could do first, so the first things that come into each one of these, and remember that there's a multiplication sign between the two. Okay, our first is x times x, and so x times x is x squared. So we've done this. The next thing to do is outers. So this is on the outside, and this is on the outside, and remember that the plus goes with the 3. So plus 3 times x gives us plus 3x, yeah? So we've done the outers. The inners, Ellen? Plus 1 times x, so we can just go plus x, yeah? Yep. And our last, Jess, what are our lasts in this? Yep, plus 1 times plus 3 gives us 1 times 3, which is 3. And then where we went from that, we said we can collect like terms, and there's nothing like to x squared. There's no other squared symbol, so that must stay on its own. And there's no other just number on itself, so that must stay the same as well. See that they both come down automatically. And the sign belongs to the number which comes after it. Okay? We've got 3 oranges, plus 3 oranges, and we're plussing another 1 orange. So, Jaden, we've got 4x. And so our answer is x squared plus 4x plus 3. Okay? I'll show you a brief way of going about that without foil. The other way of going about it without using foil is to say we're going to multiply that by that. And then we're going to multiply that by that. Then we're going to come in here, we're going to multiply that by that. And then we're going to multiply that by that. We collect like terms, and we get the same answer. So there's 2 ways that you can do it. You can do it using the arrow system, or you can do it using foil. Hands up if you understand foil better than the arrow system. Yep. Hands up if you're okay with the arrow system and you use that system. That's fine. Okay. If you're looking at the arrow system, that's probably okay when we look at trinomials. Because what happens with a trinomial is we're going to multiply x by everything that's in here. And then we're going to multiply 1 by everything that's in here. Then we're going to collect like terms. So similar process, yeah? Jess, I'll need to sit with you obviously. Okay. But similar process to what we've been doing. Alright? So to start with, we're multiplying x by x squared. Okay? So that's sort of saying x times x times x. Okay? What could that be? What could that represent? It could represent x cubed, couldn't it? X to the power of 3. X to the power of 3, because we knew that if it was 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. That could look like that, or it could look like that. Yeah, anytime we're multiplying anything by itself, it can be raised to the power of 3, or however many times. We all understand that, don't we? So we've done that first one. Okay, what would we multiply together next, Jaden? X by x. X by positive x. Remember, the sign belongs to that which comes after it. And x times x, Jaden, is x squared. Good stuff. Last thing we've got to do is x times positive 1, which gives us positive x. Okay? What would be the next step to do? Oops. 1 times x squared. Positive 1 times x squared would give us x squared. 1 times positive x gives us x. And 1 times 1 gives us 1. Are there any other x cubed units there? No, there's not, so that must be left on its own. Are there any other x squared units here? Yes, there is. There is a positive 1 here, and there is a positive 1 here. 1 orange plus 1 orange gives us 2 oranges. Remember, we're adding them, so because we're adding them, alright, it remains as x squared. What else could we do now, Ellen? Awesome. Plus x, which gives us plus 2x. Okay? One little hint that might help you is you're starting to go like this. I've done them. Okay, then I did them. Now I've done them. That leaves me with plus 1. Can we simplify that any further? No, we can't, because there's no other cube, there's no other squared, there's no other number with a pronumeral alongside it, and there's no other just number by itself. With binomials, with perfect squares, sorry, there's a bit of a rule that looks like this. Where a plus b is all squared, you square the first number or letter, you square the last number or letter, and you multiply the 2 number or letters inside and multiply it by 2. Okay? That's a bit of a rule. Alright? Now, initially you're going to go, what the? Alright, but I'm just going to show you that x plus 1 all squared would look like this, wouldn't it? Which is the difference of 2 squares that we were doing before. Sorry, the binomials that we did before. So we could do it by expanding it out like this. We could do it this way. Yeah? X times x, x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. We're left with x squared plus 2x plus 1. So we could do it that way. We could use the whole FOIL process there, and we could go through that lengthy process. Okay? Or we could say, let's use this difference of 2 squares rule. We're going to square whatever's first up. Then we're going to times by 2 everything that's inside there. And then we're going to square whatever the last letter is, or last number, and that is 1 squared. That leaves us with x squared. 2 times x times 1, 2 times 1 is 2. 2 times x is 2x. 1 squared is 1, because it's 1 times 1. Okay, so this is just using a formula to try and solve a problem. And over time, what you'll be given is lots of formulas, and you'll have to work with them. Alright, so it's just leading you into working with an equation that always works, I suppose. This is really simple, a simple version. There will be more difficult ones, and I can explain them to you more.